Hey guys! Today I will tell you about what is development length. So move toward our today's topic. Development length. A development length is the minimum length of the bar needed on either side of the point of greatest steel stress in transferring the bar's force to the surrounding concrete through a solid bond and preventing the bar from pulling out under tension. What is development length? A development length is a piece of reinforcement bar that needs to be implanted into or forecasted into a column in order to achieve the necessary bond strength between both the concrete and steel. According to rule, each side of the tension or compression member at any section must be developed by providing an appropriate length in slabs, continuous beams, and column beam joints. The development length is provided. Purpose of development length. The availability of appropriate development is a crucial aspect of safe construction practices. The proper length for reinforcement bars must be provided, and it will be susceptible to failure due to slippage of joints, bonds, anchors, and laps. Development length formula. The equation below is used to determine development length, where L, D, is the steel bar's embedded length for every given bar diameter. This equation is used to determine the required length in millimeter. Both the working stress procedure and the limit state method are determined using the same formula. The previously stated formula is used to calculate the required development length in millimeter for any specified bar diameter. Factors affecting development length: concrete's compressive strength, concrete density, rebar clear cover, rebar center-to-center spacing, rebar coating. Concrete's compressive strength. The development length needed for bars is inversely proportional to the concrete's compressive strength. So if the concrete's compressive strength were higher, this length needed for bars would be lower. Concrete density. The development time must be increased if lightweight concrete is being used. Rebar clear cover. If we extend the clear cover, this length will shorten. Rebar center-to-center spacing. If the bar spacing is increased, there will be more concrete available for the rebar to withstand. Horizontal splitting. In beams, the bars are placed close together, 1 or 2 bar diameters apart, while the distance between the bars is greater for slab footing. Rebar coating. Epoxy-coated rebars are sometimes used in projects where the structure is exposed to corrosion-causing environmental conditions. The bond strength among both concrete and rebar is reduced in such circumstances, requiring longer development times. Advantages of development length. For reinforcement steel and concrete to function together without slipping, a strong enough bond must be provided to maintain the structure's integrity and allow it to carry the loads, assist in completing the stress transfer process. The perfect bond between them ensures that the plane section of a structural beam stays plane even after being bent. This design involves the reduction of reinforcement steel. This length becomes absolutely crucial. The development and lap lengths, as well as the tension reinforcement for continuous beams and cantilever supports, must be checked for structural stability. Disadvantages of development length. If we provide less development time than is necessary, the structures will be more vulnerable to failure from joint slipping. In such circumstances, the failure will occur at joints and laps before the reinforcement bars eventually break, rather than the bars breaking first. If you enjoyed our today's video, then like and share our today's video and subscribe our channel.